Hello everyone, today I will be reviewing sampling distributions, and this will include the following subtopics, which are distinguishing between the distribution of a population, the distribution of a sample, and the sampling distribution of a statistic, the 10% condition, the central limit theorem, the large counts condition, and using a normal or t-distribution to calculate probabilities if appropriate. The population distribution is the distribution of all the units in the population, and remember to use the correct notation. The parameter for the population size, the symbol for that is capital N, the proportion is P, the mean is mu, and the standard deviation is sigma. And obviously P is for categorical and sigma is for quantitative. A sample distribution is the distribution of all units in the sample, and that is taken from the population. And again, use the correct notation. Lowercase n is the sample size. The proportion is p hat for categorical, and the mean is x bar, and the standard deviation is lowercase s. And this is for quantitative. And a statistic is for a sample and a parameter is for the population. A sampling distribution is the distribution of the statistic from all the possible samples. The mean of a sampling distribution of an unbiased estimator should be the same as the true population parameter, but this does not necessarily hold true for biased estimators. The mean of the sampling distribution of p hat is equal to p, and the mean of the sampling distribution of x bar is equal to the population mean. And again, use the correct notation. It's inside this slide. The standard deviation of the sampling distribution of p and x bar is on the slide as long as a 10% condition is satisfied. This establishes independence or close enough to independence when sampling without replacement, and the sample size has to be less than or equal to 10% of the population in order for this condition to be satisfied. The large counts condition is used for categorical data, and if it's satisfied, the sampling distribution of p hat is approximately normal. And in order for this condition to be satisfied, n times p, the population proportion, in n times 1 minus p, has to be greater than or equal to 10. The central limit theorem, which is used for quantitative data, says that when n is large, or in this class greater than or equal to 30, the sampling distribution of x bar is approximately normal. Using a normal distribution to calculate probabilities should be done when given in the problem. It says the population distribution is normal. To do so, first you draw a sampling distribution, then you check the conditions, then you find the z-score, and the z-score formula is shown on the slide. You find where the tail probability is, either on the green sheet or using a calculator, and on the TI-84, you type normal CDF with the lower bound and the upper bound, and the lower and upper bounds are in z-scores, so which is why you have to find the z-score. And if you're using both tails, be sure to add the probabilities of both the tails. To calculate the probabilities in a t-distribution, well, first you're supposed to use this when the population distribution is not necessarily normal. So first you draw the sampling distribution, then you check your conditions, then you find the t-score, and the t-score formula is on this slide. Your degrees of freedom is n minus 1, and always write this down. And if you're using the formula sheet, round the degrees of freedom down. Always do this. So if you have 88 degrees of freedom and the formula sheet only has 80 and 100, use 80, not 100, because 80 is the lower value. So next, you find where the tail probability is between on the formula sheet, or if you're using a calculator, you use the following command: tcdf, in parentheses, the lower bound, comma, upper bound, comma, and then your degrees of freedom. And the lower and upper bounds are in the t-scores, which is why you have to find the t-score. And if you're using both tails, be sure to add the probabilities together. Lastly, a good AP question, if you would like more practice, is 2010 number 2. The URLs for this question are on the slide. and good luck on the AP exam.